because of the brightest minds, best technology, and billions of dollars focused on preventing the ultimate disasters. Now, plane crashes on modern marvels. On July 18th, 1996, TWA Flight 800 was en route from New York to Paris. A 747 with 230 passengers and crew. The plane was just south of Long Island's shoreline when something went catastrophically wrong.
We were notified that an aircraft was missing, and then shortly thereafter we heard that boaters had found parts of the aircraft in the water, and witnesses had seen an airplane go down.
Over the next 2 years, investigators would piece together the puzzle of TWA 800 in hopes of averting future disasters and to bring reason to the senseless loss of life. But the emotional impact often obscures the truth about these tragedies. They are extremely rare. Statistically, more people will die in 1 month of traffic accidents than in 40 years of jet travel. Governments, professional unions, and private companies endlessly struggle to keep the skies safe. Still, few tragedies elicit the dread or wound the human psyche as powerfully as the crash of a commercial jetliner. They strike at our most primal fears: heights, loss of control, and even death. They also call into question our dependence and vulnerability when the technology we trust with our lives fails. In the United States, understanding these failures is the job of the National Transportation Safety Board, or NTSB. Immediately following a plane crash, the agency scrambles a GO team to investigate the cause.
NTSB will form a number of investigative groups, and depending on the groups that are formed, they'll have a set area of responsibility that they'll focus on. Focus on weather issues. Operations group will focus on pilot training, pilot background. Aircraft performance group will focus on the structure of the aircraft.
For the teams sent to investigate TWA Flight 800, the first hindrance was that the wreckage lay in over 125 feet of water. Navy salvage teams were brought in to plot the debris field with side scan and laser sonar. But what investigators found created more questions than answers.
We see pieces from the center near the wing of the aircraft. Then we have the nose of the aircraft, and then we have a much larger wreckage area that has the fuselage, wings, and all the other surfaces of the airplane. So the wreckage isn't laid out as you would expect. It's not tail, center section, nose. It's center section, nose, tail.
The debris field confirmed that the center of the plane, just forward of the wing, had been torn from the aircraft in flight. Fueled by eyewitness testimony, the press began speculating on everything from terrorism to an accidental U.S. missile firing. So many questions were raised that both the FBI and CIA joined the investigation.
In the investigation process used by the safety board, everything's on the table when we start. We collect all the pieces of information from every source. Everything's a possibility. And then as we start going through collecting more information, areas start to eliminate themselves.
Over the next 9 months, NTSB crews recovered and transferred the wreckage to the Calverton Hangar facility on Long Island. With every scrap holding a potential clue, the investigators began putting the plane back together.
Components were identified, they were placed on the floor in a kind of a two-dimensional mock-up, I would call it, of the aircraft. And then the structures people, the metallurgists, then could look at those components and then based on where they were on the aircraft, try to piece together the failure mode that was involved during the accident sequence.
But investigators needed more and set out to rebuild 93 feet of the shattered plane. Oddly, once the reconstruction was complete, all the clues pointed not to a criminal act, but an empty fuel tank.
As we started putting the wreckage and the pieces together and doing the layout, it was obvious to our investigators that something occurred in that center fuel tank. The question is what?
The fumes in the tank had ignited, tearing a hole through the bottom of the aircraft, causing a massive structural failure. The nose section separated from the rest of the plane and plummeted to the ocean. After a brief climb taking nearly 20 seconds, the fuselage suffered another explosion. What remained of the aircraft then went into a steep dive, breaking apart roughly 5,000 feet above the water. But further questions remained.
Yes, the center fuel tank ignited and caused the structural breakup of the aircraft. Then you take a look at what are the possible events that could ignite the fuel and the air mixture in the tank. And it became a huge list of events that could have done it.
The investigation had succeeded in understanding the chain of events, but not the actual cause of the disaster. Still, there was enough information to enact new legislation. To save on weight, planes often fly with just enough fuel on board to complete the flight, which means some of the multiple tanks are regularly left empty. After the final report, the Federal Aviation Administration, responsible for regulating the industry, mandated that all empty fuel tanks be filled with inert gas to stop similar explosions from occurring. But the investigation exemplified one terrifying truth about plane crashes. They are often caused by a multitude of minor problems that combined end in one massive failure. And in some cases, the exact cause is never known.
Aircraft accidents right now are extremely rare events. For one to occur at this point in time, it literally takes a breakdown of dozens of links in that chain. Dozens of events have to line up for an accident to occur.
For early aviators, the story was quite different. And the science of accident investigation, like that used on TWA 800, wasn't even on the horizon. During the 1920s, military and small personal airplanes like the Jenny dominated the skies. The crashes, though horrific, were on a small scale, and very little remained for those interested in sifting through the wreckage.
Now, the challenge in all this, of course, is if you have an aircraft that actually experiences an accident, either the pilot survives or he doesn't. If the pilot doesn't survive, you don't really understand what went wrong and how to fix it.
By the mid-1920s, the government decided federal mandates were needed to make sure both pilots and the planes being built were fit to fly. The culmination of their efforts was the Air Commerce Act of 1926.
The Air Commerce Act of 1926 established an aeronautics branch within the Department of Commerce, which is the direct ancestor of the present-day Federal Aviation Administration. Coming out of that was the licensing of pilots, the certification of aircraft, and the licensing of mechanics. From that point on, we saw a remarkable improvement in aviation safety.
But even with the improvements, more was needed, and many safety issues went unnoticed until highlighted by national tragedies. In 1931, Newt Rockne, the famous Notre Dame football head coach, was mourned in the national press when the 10-passenger, mostly wooden airplane he was traveling in literally came apart at the seams.
The wing literally fractured and failed because of problems with the design of the wing and the fact that it had exceeded its load limit. People, I think, instantly recognized that a change had to be made in aviation. We went almost immediately, we saw these metal aircraft, which had been under development actually for quite some time. We saw these metal aircraft start to predominate in the minds of airline planners and design teams alike as the way to go in the future.
But even with metal fuselage and wing construction, flying was still a risky business. Crude instruments also played a major role in early airplane crashes. Flight navigators used maps, rulers, and newly developed radio flight beacons to plot their course. Small variations in measurements, especially during bad weather or limited visibility, could lead to tragedy. In 1945, a wayward B-25 crew flying in bad weather over Manhattan miscalculated their location. As a result, the captain flew into the heart of New York City, striking the 79th floor of the Empire State Building. The crash killed all 3 on the plane and 11 more on the ground. But small crashes were about to be eclipsed as revolutions in aviation technology put more people in the air than ever before.
Two great revolutions that occurred in aeronautics were the development of the turbojet engine, which promised you 500-mile-an-hour flight speeds, and the development of high-speed aerodynamic theory and wing design that enabled you to develop airplanes that could fly very efficiently at very high speeds.
The first commercial aircraft to truly take advantage of these new technologies was the de Havilland Comet. Built in 1949 and able to hold 36 travelers, the Comet became the world's first turbojet passenger plane. But it's also remembered for its disastrous safety record.
A comet disappeared on a flight over the Mediterranean. Then another comet disappeared. There had been other incidents and accidents of the comet involving other things, but now all of a sudden you had this disappearance of airplanes and some evidence that something had occurred to them so suddenly that the crews had been unable to convey any sort of message to Earth. Clearly, these airplanes had disintegrated. What had caused this?
By looking at the wreckage, investigators concluded that the comets were breaking up due to metal fatigue. Cracks in the fuselage formed at the corners of the plane's square windows. The fatal flaw changed aircraft design. From that point on, round windows would be designed into fuselages to eliminate stress points. But as one group of engineers looked for ways to keep planes in the sky, another group looked for ways to bring them down. For the FAA, one of the best ways to prevent plane crashes is to cause them. NTSB GO teams are always on call and must be en route to a crash site within 2 hours of being notified. Plane crashes will return on Modern Marvels. On July 11th, 1961, United Airlines Flight 859 crashed while landing in Denver. The plane had left the runway and smashed into an airport construction site. The impact tore through the bottom of the jet and left the plane engulfed in flames. Remarkably, of the 122 on board, 104 survived the crash, and more importantly, escaped a killer that had plagued aviation from the beginning: fire. Since the FAA's inception in 1958, it has worked hard at improving ways to get passengers lucky enough to survive a crash off a burning aircraft.
Many of you have noticed what's called the disco lighting or the floor strip lighting. That's been a wonderful thing to prevent people from turning down the wrong set of seats and finding that an exit wasn't there.
Countless flame tests performed over the decades at the FAA's William Hughes Research Facility led to breakthroughs in fire-resistant seats and aircraft interiors.
We have seen clearly a very great difference in design application from, say, the jetliners of the 1960s and 70s with the kind of materials they had that readily gave off those kinds of toxic and lethal clouds to the kind of materials you have in a new jetliner or a new aircraft today.
Some of the most dramatic lessons about fire and other problems, such as aircraft structural integrity, were learned from full-scale tests. These well-planned disasters helped scientists understand the forces at work during the real thing.
The Federal Aviation Administration would take an old transport airplane, they would load it with perhaps an experimental fuel or an experimental fire retardant or things of this sort, and then they would run it down a track.
One of the most elaborately planned crashes conducted by the FAA was performed in 1984 at Edwards Air Force Base in California. A remotely piloted Boeing 720 aircraft was the laboratory. The purpose of the crash was to test a new fire-retardant fuel. Crash test dummies, interior probes, and high-speed cameras were also installed to measure the forces at work and to see what might be done with future aircraft design to ensure that all passengers could walk away from a survivable crash.
Well, clearly, if we take a look at what's happening to that aircraft as it hits the